Hey guys, welcome to our first PowerPoint on the scientific method. We have spent the last few days exploring ourselves what the scientific method is all about. This is going to be your first formal PowerPoint and note describing the steps of the scientific method. The scientific method is a series of steps to follow to gather information and solve a problem or answer a question. So remember, you start with an observation. So you make an observation about something in the world. You do some background research or information on it, and then you pose a question that you want an answer to. So this is where the research question comes in. The research question is a question that asks what you are investigating or trying to find out by doing the lab. We always start with a research question. The research question is specific and includes variables, the conditions in which the experiment is going to be done. So a variable is any condition that can change an inquiry or an investigation. There are two types: an independent variable and a dependent variable. The independent variable is the variable in the experiment that you are actually deliberately changing. So you are controlling this variable. You are changing it in some way. The dependent variable is the other variable that you want to see if it's affected by the independent variable. So it changes in response to the independent variable. So the independent variable causes an effect on the dependent variable. It's the condition that you change in an experiment to see if the dependent variable will be affected. The dependent variable is the condition that you measure in an experiment, the one you want to see how it changes in response to the dependent variable. For example, if you're doing an experiment on if sleep affects students' scores on tests, then how long you sleep would be the independent variable. That's the variable that we can control. We can make a student sleep less, we can make a student sleep more, and we can see the difference. So that's the independent variable. That's the variable that we can actually control. We can change it. The dependent variable would be the actual test score. So does the test score become affected by the hours of sleep? Your test scores would not affect how long you sleep for. So do you see the difference between the two? Take a few minutes now and read over these three examples of the differences between independent and dependent variables so you can get a better understanding of which variable is independent and which variable is dependent. Remember, the independent variable is the one that you are controlling. The dependent variable is the one you are measuring to see if there was a change in it because of the independent variable. Next comes our hypothesis. A hypothesis is a prediction of what you think will happen. It's an educated guess. We write our hypotheses in an if-then statement. So if we go back to the example of sleep affecting test scores, then I may write my hypothesis as if a student sleeps more, then their test scores will be higher. That is my prediction of the relationship between test scores and sleep. Next comes a list of the materials that you will be using in your experiment. It is a detailed list of chemicals and materials that you used during the lab. It has to be detailed and it must include all materials. Chemicals are listed first and then equipment. You separate each item using a bullet, a point. The procedure comes next. The procedure is a step-by-step list of instructions that explain how the lab was done. We write the procedure in past tense and we number each step. The steps must be specific and detailed. Remember, you want someone to be able to replicate your experiment step by step. So you have to be very clear on how to do the experiment if you want that to happen. The procedure can be written in short, complete sentences, but it must go in order. So you have to list the points in sequential order, first, then last. And we never use personal pronouns. We're always writing in past tense. This is a professional lab report. After the procedure comes your results. This is where you collect your raw data. Your observations of reactants and products, what you saw happening during the reaction, and any measurements that you've taken. You record your results in a table format. The tables can take the form of qualitative observations, which include physical properties, so it's a description of what you see, or you can have quantitative observations, which involve measurements. It's something that you have to measure. Once you have your observation table completed, you can then process your data, which can include a calculation and or a graph in order to summarize your data. It is always easier to interpret results on a graph than it is on an observation table. It summarizes the information in a much easier to read format. Next comes the discussion. The discussion is where you compare your expected results with those obtained. So what you thought was going to happen versus what actually happened. If there were differences, how can you account for them? You would be specific here. Were there flaws in the procedure that maybe affected the results? You can list them here as well. Are the measurements and observations reliable? You can suggest improvements to the procedure. Sometimes I'll actually give you a specific question to discuss in the discussion portion of the lab report, but sometimes I won't. Lastly comes the conclusion. This is where you identify if your hypothesis was supported or refuted. So your if-then statement, did you prove it right or did you prove it wrong? You always refer back to your data to support your statement here. And then lastly, you want to state what you know for sure as a result of the lab. This is the end of our slideshow. I hope that you have a better understanding of what the scientific method is now. Tomorrow in class, we'll do more work on it. See you guys later.